inclusive. So a student being a girl and a student being a soccer player. Let's see, can both of those events happen at the same time? Can you be a female soccer player? Yeah, I don't see why not. Like, I know there's a couple of you girls in like functions in Drake that play soccer and are female, so both can happen. So yes, both. Well, not yes. I meant to say that is inclusive when both can happen. I'm just gonna put an I for inclusive. Both can happen. No, for part B, student is being a boy and a student is playing on the BHS volleyball team. But if there's a male volleyball team, then yes, it can happen. I don't know. I don't think there is a male volleyball team, but let's just say there was a male volleyball team at BHS. If there was, I'll say male team. So boy and playing on the volleyball team, you can be a boy and play volleyball. So both can occur. So that's inclusive since they both can happen. And happen. Now for part C, a person is being a resident of Minnesota and a person a resident of Wisconsin. Can both of those happen at the same time? Can you live in more than one place at once? No, you cannot. So this is exclusive, mutually exclusive, because you can't live in two places at once. Now for part D, a number being prime and a number being even. Well, besides number 2, because 2 is technically a prime number, let's say, since all prime numbers you can't divide a prime number by anything besides itself or 1. And if it's an even number, it can be divided by something because if it's an even number, it can be divided by 2. So we know that cannot happen at the same time. So they both can't happen at the same time because prime numbers are not even, except for 2, but we're not including that. Starting to make some more sense. So let's consider a deck of cards, and we're going to draw one card from the deck. So it's asking if this question number 1 here is exclusive or inclusive. So a probability, let's say, of drawing a red card and blue. Can you, not blue, black. Can you draw a red and a black card at the same time if it's just one card? That probability is going to be 0 because it is exclusive, because a card is either black or it's red. You don't see a card that's half black, half red. But if it says probability of red or black, well, every single card in a deck is either red or black. So your probability is 100% because every single card is either red or black. So that would be probability of red plus probability of black. So when you have mutually exclusive events down here, this little key, when it's A or B, and if they're exclusive, then you can just take the probability of A plus the probability of B when they are exclusive. So that's why we could take probability of red was 1/2, plus the probability of drawing a black card, 1/2, to get you to 2/2, which is just 1, or 100%. Now for this example here, we're doing the same thing where we're going to determine if it's exclusive or inclusive. So our outcome of drawing a 4, and then the outcome of drawing a black card. So let's see. Our probability of drawing a 4 or a black card. Okay. Can both happen at the same time? Is it exclusive or inclusive? Well, you can indeed draw a card that's 4 and that's a black suit, for instance. So that would be inclusive. They can happen because there is a black spade and black, plus black club. Those are the 2 black 4s you could get. So if we were to add our 2 probabilities together, get 13, because our chances of drawing a 4 is 1 in, sorry, it's, wait a second. Well, I got ahead of myself. Let's go back. So now we know it's inclusive. Forgot to do this part. So when we know it's inclusive, and we're asking if it's an OR statement here, then we'll take our probability of A plus our probability of B, and then subtract out the occurrence of them happening at the same time, because then we want to get rid of those overcounting like we did for those Venn diagrams, and not Venn diagrams, for the two-way tables. So we'll have, let's see, our chance of how many 4s out of 52. If there's 52 cards in each deck, how many 4s are there? Well, there's 4 4s. And then how many black cards are there? There is 26, because that's half of the deck, so 26 over 52. And that's going to be 30 over 52. But then we have to also subtract the probability of them both happening. So 30 minus 2 over 52 is then going to be 28 over 52. And that is going to be, let's see, what is 28 divided by 52? 28 divided by 52, that's about 50.3 or 0.538, which is pretty close to 54% if you round up. So you have about 54% chance of getting a 4 or a black card. Okay. So now we have a probability of 4 and black. So what's the probability of them happening at the same time? Well, we know that there's only 2 cards I just listed up here, 2 cards that are both black and a 4. So that's just 2 over 52, which if you take 2 divided by 52, it's going to be 0.038, which is about 3.8% if you move that decimal place over. So again, you're going to want to make sure you have these written down for both pages. And if you have any questions, please feel free to email. Don't forget to do your homework quiz and your attendance check-in.